All right, so for this video, we're gonna learn how to factor. This section is gonna be broken into a few different segments because there's a lot to unpack. But we're just gonna get started and build from it. So the idea of factoring is that you look at some expression that has some common term or common factor, right? And the idea is you want to undo. I always say you undo a distribution to get it back to where it was before. So when we look at this first expression, we see two terms. We got 7x and 7y. And the idea here is we want to find something that is common to both the 7x term and 7y term and see if we can factor it out, so, sort of divide it out maybe. So we look for something that can divide both 7x and 7y. Now in this problem it's pretty obvious. Both 7x and 7y are divisible by 7, which means 7 is a common factor. So what we do then is we say, okay, if we were to divide this whole thing by 7, what would it look like? Well, there would be just an x plus a y left in the middle. Now, that 7 has to go somewhere, so we bring it outside the parentheses. So now we have 7 times x plus y. Now, the reason this works is because if you note, I'll just do it. If you note that if you simplified this, 7 times x plus y, if you were to distribute 7x and then 7y, you would get what you started with, and that's sort of the whole point. So what I want you to do, the next two examples are ever so slightly more complicated. So I'm gonna stop for a second, pause the video, take a moment to see if you can solve those, and then check our answers real quick. All right, so pause the video and see if you can do it. All right, so let's check our answers now. Excuse me. So in the second one, I'll scoot this up a bit. The second one, we see 3a plus 9b. So we need the biggest value we can come up with that divides both 3a and 9b. Well, can't divide, b by a or a by b, so it probably has something to do with the numbers here. So, all right, well, 3 and 9 are both divisible by 3, so we can factor out a 3. So we'll bring a 3 outside of our parentheses here, and then what would be left after we divided both of these terms by 3? Well, 3a divided by 3 is just a, and then 9b divided by 3 is just 3b. And if you want to check your work, of course, you can multiply 3 times a and 3 times 3b, and you get 3a plus 9b. Number 3 here, we can do the same thing. We say, all right, 3x minus a wx. All right, so this one's a little bit trickier because we see that there's not a number that is common to both terms. So maybe, I guess we have to look for a letter. Well, this one has an x, and this one has an x in it, so we can factor out an x. So if we were to factor out an x, we'll put the x outside the parentheses here. Both of these terms divided by x, well, 3x divided by x is 3, and then awx divided by x is aw. That's it. The next 3, 4, 5, and 6 here, again, they're a little bit more difficult than the previous 3, so I'm going to pause the video. I'm not going to go through an explanation. Well, I'll go through an explanation on 4, 5, 6. 6 is a bit tricky there, so I might give you a bit of help on 6. So again, pause the video, see if you can figure these out, and then we'll check our answer. All right, so there's the answer to 4, right? It's pretty straightforward. All 3 terms have a c in it, and that's the only thing they have in common. So you factor out a c, you get c times 4 plus a plus b. And if you were to distribute the c, you'd end up back where you started. So now it's been factored. Done. For number 5, I'm going to do something a little bit different. This one has variables with exponents in them, so I'm just going to expand it, write it in its expanded form, and then compress it back. Hopefully you'll see why. If you don't like this method, you don't have to do it. It's not going to bother me. But I just want to see, I just want you to see exactly what's going on. So on number 5, what what I'm going to do, I'm going to expand each of these three terms into each letter so that there's no exponents, right? So this first term, we can rewrite this c d h cubed as c times d times h times h times h, right? Oh, that's not on the paper. There we go. Sorry about that. So we can rewrite the first term like this. You know, these are all variables being multiplied by each other. That's what an exponent is. It's that value multiplied by itself 3 times. The next term, we have c squared times d times h. So we can write c times d times h. And then for the third term, c cubed plus d squared plus h squared. So that's 3 c's being multiplied times 2 d's being multiplied times 2 h's being multiplied. And now you know why people use exponents, right? That's a lot. Okay, so now what we'll do is I'm going to set up down here what my answer is supposed to, the structure my answer is supposed to have, right? It's going to be 3 terms separated by plus signs, and there's going to be some C's, some D's, and some H's in there. So now let's go through. How many C's are in each term? Well, the most amount that we have is 3, but the most that all of them share is just 1. So I can go through and divide out or factor out one of the C's from each term. Put that a little too close. So I can factor out one of the C's from each term. Now I'll move on to the other terms, the D's. Well, the most that all of them share is just 1 D value. So I can factor out 1 D from each of the terms. And then it turns out the same with the H's. This one has 3, this one has 2, but this one only has 1. So we can only factor out 1 H from each term. So there we go. There's the H. And now what we have left over, well, H squared on that one, plus C on that one, and then C squared, D, and H. So C squared, D, and H. And that's our answer. Maybe I'll scoot this over to be a little more legible. Plus C squared times D times H. And there you go. All right. One more before this video ends, and then we go on to the next video. So number 6, this one's a special case as well. So here you'll see. So we have u squared plus 3u cubed plus 17u to the 4th. I'm not going to expand it like I did the first one. I don't think you'll need me to, but I mean, you can if you like. So we have u squared plus 3u cubed plus 17u to the 4th power. There's not any one numerical value other than 1 that all 3 of these share. So there's no there's no greatest common factor other than 1 that we can factor out numerically. So that's off the table. So we got to think about the variables that we can factor out. Well, it looks like that the most u's being multiplied by each one of these terms is 2 of them. We have u squared, u cubed, and u to the 4th. So I can factor out a u squared from each of these. I'll come back to this first term. The second term, 3u cubed divided by u squared would just be 3u. And then 17u to the 4th power divided by u squared would just be 17u squared. Now this first term, the reason I left this blank is because a common mistake is to, well, we factored it out so nothing goes there. Well, that's not true, is it? When you're dividing, essentially. You need something there so that when you distribute or when you multiply it by u squared, you get u squared. Well, that narrows it down a bit, right? What value can you multiply by u squared to get u squared? Well, that's just 1. So when you factor things out, make sure that you don't unintentionally factor out the whole thing and not leave something there as a placeholder, like 1. All right. The next problem set will be on the next video. I'll reference these problems, but that's a good stopping point for now.